Hello everyone, welcome to YourPedia. Today I am going to discuss one question that was asked previously at an ISRO interview for an EC graduate. Let's go into the question. This question is about filters. Okay, let's enter into the question. See, the interviewer given this circuit. They asked the candidate to draw series RLC network. Yes, and he said the circuit is operating in AC analysis. The analysis is AC analysis. Input is Vi of t, and this is resistance in ohms, and this will be j omega L in ohms. This is 1 by j omega c. 1 by j omega c in ohms, and the interviewer asked to take voltage across this combination as output. This is V naught of t. Yes, see, many students will fix like output is this one. Any possible variable in this system or circuit can be taken as output. See, voltage across resistor can be taken as output. Current in the circuit also can be taken as output, or voltage across only inductor can be taken as output, or voltage across only capacitor can be taken as output, or voltage across these two can be taken as output. So the interviewer asked to select voltage across these two, means VL of t plus VC of t as the output. If V naught of t is the output and V of t is Vm sin omega t, yes, he is saying that Vi of t is equal to Vm sin omega t, and omega is varied from 0 to infinity. He is varying frequency from 0 to infinity. If frequency varies, what happens? Resistance will remain same. R is in terms of ohms, and it is independent of frequency. That value will be fixed. But whereas when you come to this inductive reactance and capacitive reactance, as frequency changes, this value will change as well as this value. Now he is saying if the frequency is varied from 0 to infinity and the input is Vm sin omega t, then this particular circuit will behave as what kind of a filter is the question. Okay, I'll repeat it. If the frequency is varied from 0 to infinity and the output is the combined voltage of inductor plus capacitor, then this particular circuit will behave as which type of a filter is the question. Let's start analyzing. See, the analysis for low pass and high pass filters is different, but the analysis for other filters, we have band pass and band reject filters, is going to be different. See, low pass, high pass is possible only with one energy storage element, but if you want a band pass or band stop or band reject filter, we must have two energy storage elements if we are going with passive elements. Okay, now let's observe this circuit carefully. See, at some frequency definitely resonance will occur. Yes, at some frequency, we are with AC analysis, as we are varying frequency, at some frequency resonance is going to occur. At what is that frequency? See, first of all, what is resonance? This question also can be asked. If you start explaining like this, sir, at some frequency. See, they don't want only the answer. You may give the answer as, sir, band stop filter, or band pass filter, or high pass filter, or low pass filter. That is immediate for them. They will see your approach towards the question, in what way you are approaching. So you have to start explaining like this, sir, as we are varying frequency from 0 to infinity, resonance will occur. Immediately the question will be, what is resonance? Resonance is the condition at which input frequency is equal to system frequency. Many people, especially those who are students now, those who are studying, they have misconception about resonance. They will speak resonance only with respect to electrical circuits. You take any physical system, if the input frequency is equal to system natural frequency, then a condition is going to happen in that system, or some phenomena is going to happen in that physical system, physical dynamic system. In fact, that condition or that particular response, I can say resonant response. Okay, see, that particular condition is called as resonance. So input frequency is equal to system natural frequency. Okay, what is the natural frequency of this system? Omega is equal to 1 by root LC. You can find omega equal to 1 by root LC radians per second. You take any values of L and C when you are varying frequency from 0 to infinity, then definitely this is input frequency. This omega is input frequency, this is system natural frequency. Then resonance is going to occur. Under resonance, under resonance for this circuit, yes, this impedance and this impedance both are exactly equal and opposite in direction. Mod XL is equal to mod XC, and XL plus XC is equal to 0. If these two are going to become equal to 0, then this will behave like a short circuit. Students, what will they will do is, if the interviewer asks about resonance, they start explaining about when input frequency is equal to 1 by root LC, then a condition is going to occur that is called as a phenomenon is going to occur that is called as resonance. So interviewer is just asking what is resonance phenomena, not the condition like omega equal to 1 by root LC, or input frequency is equal to 1 by root LC, or he is not asking about in series RLC whether current is maximum or not, or if XL is equal to XC or not. No. Resonance means input frequency is equal to system natural frequency. That particular phenomena is called as resonance. Any physical system, not only electrical circuits. Okay, come here. So omega we are varying from 0 to infinity. At some value, this value is going to be equal to this value. Suppose if L is equal to 1, C is equal to 1, when omega equal to 1, we are going to get resonance condition. Okay, during resonance, yes, let me write, if omega is equal to omega n, I'll write this one as omega n, omega I call this one omega input, then resonance occurs. So the condition at which omega equal to omega I is equal to omega n is called as resonance. At resonance, or during resonance, or at resonant frequency, I write at resonant frequency, at resonant frequency, yes, the circuit is like this. This is R in ohms, and at resonant frequency XL plus XC, R instead of XL and XC, I'll write like this: VL plus VC is equal to 0, since XC is equal to minus of XL, or XL is equal to minus of XC, both are same. Or I can say simply, or XL plus XC is equal to 0. Current is same because it is series circuit. Yes. Now this particular one will behave as short circuit. Yes, observe it carefully here. This is the short circuit I am representing. Short circuit means we will represent with a thick line. Generally we are engineers, yes, we have to follow the technical terms and diagrams carefully. Okay, short circuit, yes, what is voltage across this one? V naught of t is equal to 0. The total voltage is going to appear across this resistance. Yes. Now let me draw the characteristics, frequency response characteristics. This is omega, this is V naught of t. This is omega, this is V naught of t. Observe it carefully, ma. I'll draw it once again. Yeah, this particular graph will give you the complete clarity about what kind of filter it is going to be. This is omega and this is V naught of t. Yes, this is 0. When omega equal to 0, capacity is going to behave as open circuit. 1 by omega c, omega is 0, 1 by 0 will be infinite, capacitive reactance is infinite. Then how much will be the voltage? The total voltage Vi is going to appear here. Yes, this is Vi of t, or Vi simply. I'll write it as whatever you have at the input, that is going to appear. Now this is the frequency at which resonance is going to occur. This is omega I, please. we are varying input frequency, but at some particular value of omega I, that is going to be equal to omega n. Now at that point of time, what is the voltage V naught of t? 0, means it is decreasing like this. Yes. Finally, at omega equal to infinite, if you come here at omega equal to infinite, yes, this is open circuit, this is short circuit, but overall it is open circuit. Total voltage is going to appear across the output. So finally again it is Vi, means it is from Vi to 0, again 0 to Vi, 0 to Vi. Yes. What kind of filter is going to have this type of characteristics? Band stop or band reject filter. This is what? Band stop filter or band reject filter. So these are the exact characteristics, but approximate characteristics we are going to take for a band stop or band rejector filter will be like this. Yes. See, what we drawn in blue color is the exact characteristic. Yes, these are the exact characteristics. These are the approximate characteristics. See, approximate, this is exact frequency response characteristics. So if you are selecting the voltage across inductor plus capacitor as output, then that particular circuit will behave as what filter? Band stop filter. Some band of frequency is going to be attenuated. Why? Because that output, see, for that particular range of frequency at the output, the voltage is very less. Means we can say that that particular range of frequency input is attenuated, that is not reflecting at the output, so it is band pass or band reject filter. So the extension for this question will be like this. If suppose if the interviewer want to ask, now he will change his question. Suppose instead of taking voltage across inductor and capacitor as the output, if voltage across a resistor is taken as output, yes, or same diagram you can take, same diagram, why to get confused? Yes, this is the resistance and this is inductance and capacitance. Yes, this is resistance in ohms, this is j omega L, this is 1 by j omega C, yes. Now if we are taking voltage across a resistor as output, yes, this is plus minus Vi of t, yes, this is plus minus Vr of t. Now if frequency is varied from 0 to infinity, for omega equal to 0, what is Vr of t? Vr of t will be 0. Why Vr of t is 0? See, one must have very good grip on network analysis techniques. Okay, simple network analysis techniques. What is Vr of t? First of all, at omega equal to 0, let's see what happens. At omega equal to 0, let me write the total analysis. At omega equal to 0, see, I can say inductor XC is equal to infinite. If this is open circuit, the total current that is flowing, is equal to 0. I of 0 will be 0. I'll write it as, instead of I of t, I'll write that one as I of 0 is equal to 0. If I of t is equal to 0, then what is Vr of t? Vr of 0 will be 0. Why? Because since Vr of t is equal to what? R into simply I of t. Yes, R into simply I of t. Okay. Now at omega equals to omega n, xc mod xc, or I can write like this. Okay, I can write like this. XL plus XC is equal to 0 and Vr of t is equal to Va of t. Why? Because this particular part is behaving as short circuit, therefore entire voltage is going to drop across resistance. Vr of t is equal to Va of t, and at omega equal to infinite, XL is equal to infinite. That implies I of infinite will be 0. Why? Because this is going to behave as open circuit, therefore current is equal to 0. Again, yes, Vr of infinite is equal to 0 since current is equal to 0. Now if you observe, initial value is 0, final value is 0, in between it is going to be a total value, means total input is going to appear across the output. Yes, let me draw the characteristics of that one. Yes, from this one you must be in a position to recognize, see, this is input frequency, we are varying from 0 onwards. Yes, this is VR of t. Let me draw the graph of it. If I draw the graph of it, initially 0 volt, yes, in between, yes, it is not sinusoidal waveform. Actually, one should not feel it as sinusoidal. Yes, what is this one? Vi of t. So low frequencies are not allowed, high frequencies are not allowed, but in between some frequencies are allowed. That kind of filter is called as what filter? Band pass filter. Previous one is band stop filter. Yes, sir. This is band stop or band reject filter, but this present one is a band pass filter. Yes, this particular circuit is going to behave as what filter? Band pass filter. Yes, so these are the actual characteristics. Now this one is approximate characteristics. These are approximate characteristics. These are exact or actual characteristics. Frequency response characteristics, magnitude versus frequency. Okay, so this is going to behave as what filter? This is going to behave as, yes, this, after looking at this one, it is a band pass filter. What is this filter? Band pass filter. So this way you have to explain to the interviewer, then definitely interviewer will impress with your explanation. But whatever the concept he is asking the interviewer, start from basic. If you start analyzing from basic, then definitely you can answer any question. See, especially in this concept, only two things are important. Omega equal to, sorry, not two things, three things are important. At omega equal to 0, at omega equal to infinity, at omega equal to omega n, the behavior of the circuit. See, last very important note point I am going to give with respect to the analysis of filters. Yes, very important note point I am going to give. Yes, observe carefully here. Note, that is, yes, to check what type of filter the given circuit is, the given circuit is, test the system at three frequencies, those are omega equal to 0, omega equal to omega n, comma omega equal to infinity. Yes, if you do this, then definitely you are going to identify very simply what type of filter the given circuit is. Okay, so this way you have to analyze if you want to answer any filter questions, either it is passive filter or active filter. Thank you.